biosignals and creating new products that are used by end consumers in the market. So before I get into this, I mean we are all have this basic understanding of biosignals. We are using them in our everyday research. We are researching on them. We are collecting data. We are simplifying them. But what happens after they are simplified? There is a big gap between the research that we do and the product development. So I'll just be talking about some application and some companies who have already used these research papers and developed some products. But before I get into this, I'll just introduce my company. So the company is called Gentech. We are based in Delhi. We have been in this market for more than 20 years now, 25 years now. And we cater to various domains. So we try and get the most sophisticated technology to the country. These are the tools that can be used by the researchers of India. So that will help them ease their research, get the best kind of data, and we want them to eventually create more, publications, create new products, create new innovations using these technologies. So we cater to various domains. One is education, one is human research, there is animal research. So basically, pharmaceutical companies they have a lot of requirement of seeing what kind of changes happen when they deliver different drugs. So that can be for diagnostic of a disease, or it can be for improvement or enhancement. So then there are products for sports science research. There are environmental research products and also industrial collaborations that we do. So when there are companies that are making new products and they want to see what is the impact of these biosignals, how is the consumer reacting to certain products. So in that, when they require our help in data collection or analysis of the data, we also collaborate with them. So in the human research sector, there are various domains again that we cater to. It can be various biosignals that help you capture facial expression. It can be used for neuroscience studies, for physiology studies, for autonomic function testing. It can be used for gait analysis. So there are various products that we have, but I will not be getting into the products. I will just be discussing the use cases or the application for biosignals. So the agenda will be talking about wearable technology and how wearables can be used beyond healthcare, some of the use cases and projects, and the integration of biosignals and virtual reality. So the first thing that we'll discuss is smart technology or wearable technology. Like right now, we can see that this is the highest growing market. Every day, if you see, there is a new product that is entering the market, and you can't even estimate the size of this market because it grows every few days. So there are various products that come into the market which are known as the wearable technology. Basically, what it means is that there is a wearable device that causes zero to no hindrance while you're wearing it, and it is giving you some information about your body. So it can be through because of some external stimulus, or it can be certain changes that are happening in your body. So we have heard about there are smart glasses, there are smart textiles, there are t-shirts that can monitor your thermal activity. There are t-shirts that can probably monitor your temperature, your ECG. And there are rings which are monitoring your basically PPG and your thermal activity. So they can be used for your personal healthcare. You can use it to check your person. So I'm sure you must have seen, there are a lot of ads about this ultra human ring or aura ring. So that is for your own performance maintenance. So you can see on an everyday basis how your body is performing. So what is it using? It's again using biosignals. There are smart shoes. There are bands, watches. So smart shoes. I remember that IIT Gandhinagar had used some EMG sensors, and they developed a shoe which could detect fall. So it was a fall detection shoe, and it is basically used for elderly people. So it will give them an alert that I think there was like a 6 second before they can alert the person that there's a possible fall that is going to happen. So like that, there are various products that are in the innovation zone right now which are using biosignals. One of the other product that I can think of is there's a company, I think it's in Germany, they have made headphones. They have made headphones that is tracking your EEG signals. And there is a mobile app which will tell you about it's like a neurofeedback system which will give you how your body is performing. Like if there is a lot of workload on your brain, if you're fatigued, if there is more alertness. So it will give you a matrix on your phone itself while monitoring your EEG. So headsets were there. Now there are headphones, which is like a new innovation that has come. And I think someone had earlier asked about that if there is a hair, then how do you measure EEG? So with dense hair also now people have come up with brush electrodes. So there are electrodes which has like a comb or a brush-like structure in the front. So that can be used in any kind of headset or any kind of cap. So it makes that space and it still gets a good skin conductance. So going one step deeper, that what is this wearable technology? It's all coming from biosignals, right? So we all understand what are biosignals. These are there are various signals in our body that can be measured. So it can be electrical, it can be mechanical, it can be optical, it can be chemical. There are various signals in our body that can be measured, and it is usually used for understanding how a human body is responding to a stimulus or any kind of change that is happening in our body. So, till now, it has always been used for research purposes or for diagnostic purposes or for understanding disorders, even for finding any kind of abnormality. And even now with AI, we can see that there is a lot of predictive analysis that is happening. So people can predict if someone is in the future going to have certain kind of diseases. But other than that, biosignals are now being used for various other applications that we will get into later. So these are some of the examples. Like for electrical, there is ECG, EMG, GEOG, EDA, which is a thermal activity, EGG, which is a gastric movement. Mechanical, respiration, blood pressure, accelerometer, force, clenched hold, understanding the grip of a system. Optical, there is, I think Sir also spoke about optical, some of the optical sensors like PPG, SPO2, FNIR, which is your functional near infrared. That will help you understand where is the activity happening, which part of your brain is more active. So it is based on a principle of deoxygenation and oxygenation. So it will emit light, and whatever is reflected back, according to that, it will understand which part of your brain is more active. So in cases of finding in cognitive tasks, you can use an FNIR sensor. One example that I have right now to give is, so AIMS Delhi, they are doing a research which is based on ADHD students. So there are some kids who have ADHD. So they are giving them certain training modules, and they are seeing if the activity in their brain is changing or not. For that, they are using FNIR sensors. For chemical, there is glucose monitoring, of course. But of course, there are many other variations. There are a lot of hormonal changes that a human body goes through. So that can also be measured for various tests. So cortisol, I think, is one of them. And there are various others. So these are just to name a few. But there are more sensors that can tell what is happening in a human body. So there are goniometers, there are gyroscopes, which can tell you angular movement. There are eye tracking devices. So there are various other devices that we can get into. Now, what is the importance of combining these biosignals? So we understand that there are biosignals, that we understand there's activity happening in our body that can give us a lot of insights, a lot of information. But once we understand each one of them, we can combine them and understand that how it can help us in different applications. So, like if you want to understand someone's autonomic system, then you will measure their ECG. You can measure their blood pressure. You can measure their HRV, which is coming from ECG. You can measure cardiac output. You can measure clenched hold. So there are various sensors that goes into understanding just how humans' autonomic nervous system is responding. Similarly, if you want to understand how a person's gait cycle is when you are walking, your balance. So for that, you can use EMG sensor, you can use goniometers, you can use accelerometers, you can use a pressure pad. So once we understand each of them, we can combine them and use it for our own research or our own application. So this is just an example. Like if I use just one signal, okay. So if I'm using just the ECG signal and my heart rate is increasing, I will not know what is the reason of the increase in the heart rate, because there can be various things in the environment that can be causing it. But if I add an EDA signal to it, so if ECG, my heart rate is increasing and my EDA is also showing a spike, that means the heart rate could have increased because of an emotional response. Now, if I add an accelerometer to this, if my acceleration is also increased, my ED is also spiked, and my HR is high, that means I've done some kind of movement, maybe a run or something. That's why all three have risen. So when I combine certain things, I will get a much clearer idea of what's happening inside the body. Like that, if I'm doing EEG, usually with EEG, people will always monitor your EOG also, because that's an artifact. Like your EEG can show a variation if you're blinking your eye as well. So to remove that artifact, that the EEG signal is valid because of some other stimulus and not the blinking of your eye, you can also measure your EOG. So it is very important to understand which signals to combine for what kind of applications. Now going further, that how we can use this beyond the healthcare. So we know that of course it can be used for diagnostic purposes, but it can also be used in various other applications like for sports, for monitoring and seeing the performance of your athlete. It can be used for neuromarketing. That I'll come to. There are various products that can be used for neuromarketing. Basically, showing a product or an advertisement to your consumer and seeing. You can measure their EG, you can measure their EDA, you can measure their ECG to see if they are getting attracted to that product or not. If there's a certain kind of excitement and there's kind of change in their body that's happening. So if you can see the EDA rising, that means there can be certain kind of excitement happening while they're seeing the product. Like that, there are various other products or various other devices that you can combine to see if there's a change happening. NPD or design improvement. So, automobile industry is widely using biosignals right now. Why? Because they want to see, one is the eye tracking system that they are using to see the focus of a driver. They're using EMG sensors to see the fatigue in driver's body, and also to create better models. Customer experience, of course, is one of them. So facial expression, voice analysis, these can be used for customer experience. Education and training, travel and navigation, travel like again like driver's fatigue, intoxication, everything can be measured. For navigation, navigating through a device also. There are EEG devices that can help you navigate a device or control a device around you. Wellness and yoga, a lot of yoga centers. I mean, India, we are a country of yoga, so we have to utilize that. So there is Patanjali right now who is using these devices to conduct researches on how these yogic nutrition, these yogic exercises, how is it impacting our body. So even to check stress levels, if there are people who are doing retreats for 1 week, 10 days, and they're seeing what were their parameters before the retreat and is there a change after the retreat, and they are also monitoring during, so they can see a change if there's their heart rate or their resting heart rate is much better than what when they're coming. That means that has helped. So, and of course there's the rehabilitation, which means you can put EMG sensors, you can put HRV, you can track their HRV to see how their body is responding to certain exercises, and you can slowly build training modules for them. So these are some of the applications. I'll just get into two or three maybe, and then we will move on. One is sports. So these the products that I'll talk about are the actual products that we have. This is an athlete performance monitoring system. It's a small sensor. It's a very small sensor that you put on your chest. It only has an ECG sensor and only has a accelerometer. Just by these two, they have created a software which can entirely tell you how a person's performing. So this is for professional athletes. It's already being used worldwide for professional athletes to see how much training do they need in a day. So again, for heart rate, they have divided that into 5 zones. If it's in the highest zone, that means they're doing high intensity. If they're in the low zone, it's doing warm-up kind of exercises. So for the coach to understand how the athlete is performing and how they should plan the training, this is one of the tools. They can also tell, based on HRT, they can also tell how much recovery has happened. Because if an athlete has not recovered and it is in the fatigue state, and you also again give them a high intensity workout, there can be very high chances of injury. So to prevent injuries, it is very important to monitor athletes. And they also do sleep analysis based off HRV and accelerometer. They can tell you if you have recovered during the sleep or not. So So this is one of the company, there's one of the product which is using again biosignals and created a whole new product just for athletes, professional athletes. There's another product which is called MyoAct. Again, they are using just EMG sensors, and with that, they have created a software which can tell you imbalances in muscle. So if I lift this arm and if you ask me to lift this arm, I can see the imbalance. Like on the software, if you can see if there's any kind of tension, if there's any kind of muscle stiffness, if there is too much fatigue or too much load on a muscle, I can see that. And with that, what they do is they have given corrective exercises. So if a physiotherapist has a patient, they will just put these sensors, see if there's an imbalance, and with that, there is a linked corrective exercise. So they can just tell them that this is what you need to do, come after 1 week. Again, this is using biosignals, creating their own product for our whole market. Other than that, there is one more. This is based on augmented reality. So it is using EEG. So if you can see on the back side of the device, it has some 6 to 8 placement of electrodes. It is taking your EEG data, and in the screen in front here there are buttons that the user has to code itself. There are buttons, so it will match the frequency of EEG with that button. So whichever button you focus on, it will select that button. Now with that button, you can control another device. So you can say switch off this, switch that on. So it can be definitely used for patients who have paralysis. It can also be used for home automation. So the applications are vast, but these are the kind of products that are already there in the market, all just using biosignals. Some other applications is like eye tracking, which I mentioned before. It can be used for neuromarketing. It will give you heat maps showing where is the person focusing on. So it will also show your path that when I see, let's say this board, what attracts me the most, and what is the path that I take to see a thing. It can be used for even education purpose to create what kind of content attracts the students. So again, various applications just using one device. Then there is facial expression and voice analysis. So a lot of there is one company called iMotions. What they do is they just use the web camera, and from that they will analyze what's happening with your facial expressions, and it will give you there are 6 emotions, and it will tell you what is the person feeling. Then you can combine it with voice analysis, with the pitch and the tone and the rhythm of the person, and if the person is happy, sad, excited, neutral, angry, then there is something called as balance, which tells you if the person is having a positive effect of something or not, or negative effect. There is arousal, which will tell you the intensity of what the person is feeling. So again, there can be various applications of this. It can be used for security purposes. It can be used for customer experiences. There are a lot of wireless EEG and FNIR sensors. EEG gives you an electrical activity of the brain, whereas FNIR gives you more spatial, which will tell you exactly the location of the brain which is active. Both of them can be combined also to get like a better understanding of what's happening, and you can design your own applications around it. Some of the use cases, these are some of the people who have used our product for different applications. So Indian Aerospace Medicines, IAM, they have used this bio shirt. This is a shirt which has sensors inside, which will be measuring your ECG, EDA, and it can also measure your respiration. ISRO is right now using this to train their astronauts. So they put them in different simulations and see how the astronaut is performing. So they can train them accordingly. So before they send them to space or any kind of mission, they have to make sure that the person is fit for that. So they create certain simulations and they track their well-being. One of the application was, this is one of the electrical vehicle company called Ather. So they wanted to do a study and they wanted to monitor thrill. So they wanted to see if someone who rides their bike versus someone who rides other bikes, is there a difference in experience? So we used ECG, respiration and EDA with them. They had booked a race track and they put one person who was a professional and one person who was new. And you can clearly see that for a professional person, the EDA was not rising. It wasn't thrilling enough for that person. But for someone who is new, you can see that the spikes are very, very high. So to monitor different kind of impacts on your body, especially like for thrill and excitement, you can definitely use EB. Another project we did was with Special Olympics. So these are athletes who had special needs. So it's that the coaches can also not understand what's happening in their body. The athletes who have special requirements cannot freely express what's happening inside the body. But when you put sensors on them and you let them train, you can see in real time what's actually happening in the body. So it basically bridges the gap and it makes it easier for the coach to understand how the person is feeling, and without causing any injury or fatigue to the athlete, you can train them. So these are just some of the applications. Then there's integration with VR. Of course, we know that with virtual reality, when you combine biosignals with virtual reality, it opens a whole new world. So because you can't always put a subject in the kind of environment you want to see, you can just create a virtual world like that, and you can see what kind of changes are happening in the body. And you will be surprised that when you see it on the virtual world, you still see the similar kind of changes in human body. And tomorrow, my teammate Nishant, he will be doing a demo. So he has a Oculus VR headset, and in there are a couple of different simulations. So you can all try it. So you can go through the simulation, and meanwhile he'll be monitoring your blood pressure, your ECG, and various other signals to show you in real time that a virtual environment can also create a big change in your body. Yeah, that's about it from me. And if you have any questions, feel free to ask. I'm also here for some time. If you want to ask over lunch, that's also fine. Thank you.